Good evening, everyone. I welcome everyone to the event AI Journeys Supervised Learning by VITMAS. And I am Arvind S. And I'll be the host for this event. We will be starting this event in a few minutes once the participants join. Once again, a warm good evening to everyone who has come to this event. I welcome everyone to AI Journeys Supervised Learning by VITMAS student chapter. And I am Arvind S. and I'll be the host for this event. Now, coming to the agenda of this event, we will be covering what's machine learning and what's supervised learning and types of supervised learning. And at last, we will be seeing two algorithms in detail and implement those in Python. For that, I'll be using Google Colab. The two algorithms that we are going to see in detail are simple linear regression and KNN algorithm. Machine learning. Now, coming to machine learning is a growing technology which enables computers to learn automatically from the past data. Machine learning is also set as a subset of artificial intelligence. Machine learning uses various algorithms for building mathematical models and making predictions using historical data or information without being explicitly programmed. Now, if we see this flowchart, it best explains the what a machine learning model would do. We would give the input data to a machine learning algorithm from which it makes predictions, and from that it builds some logical models. And when we feed a new data to the model, it will give us the predicted output. The accuracy of predicted output depends upon the amount of data, as the huge amount of data helps to build a better model which predicts the output more accurately. Features of machine learning. Machine learning uses data to detect various patterns in a given dataset. This this machine learning model, it learns the patterns from the input data that we give to it, and it will improve from time to time. Also, this machine learning, it's a data driven technology. Machine learning is also similar to data mining, as it also deals with the huge amount of data. Need for machine learning. The need for ML is increasing day by day. The reason behind the need for ML is that it is capable of doing tasks that are too complex for a person to implement directly. We can train ML algorithms by providing them huge amounts of data, let them explore the data, construct the models, and predict the required output automatically. The importance of ML can be easily understood by its use cases. Currently, it is being used in self driving cars, cyber fraud detection, face recognition, and friend suggestion by Facebook, and also in various other sectors, including finance. Classification of machine learning. At a broader level, ML can be classified into three types: supervised learning, unsupervised learning, and reinforcement learning. In this webinar, we will be restricting ourselves to supervised learning. And in the supervised learning model, we give both the input and output data to our model, from which it predicts the output if we give a new value. The other one is unsupervised learning. In that, we give only the input data and not the output, and based on the data that we give, it would group and interpret the data, and when we give a new value, it would give us the predicted output. Supervised learning, it can be further classified into classification and regression, which we will cover in the upcoming slides. Supervised learning. Supervised learning is a type of ML method in which we provide sample labeled data to the machine learning system in order to train it, and on that basis it predicts the output. The real world applications include risk assessment, image classification, fraud detection, spam filtering, etc. Now, if you see how a supervised learning model works, the system creates a model using the labeled data to understand the datasets and learn about each data. Once the training and the processing are done, then we test the model by providing a sample data to check whether it is predicting the exact output or not. The goal of a supervised learning model is to map the input data with the output data. The supervised learning is based on supervision, as the name suggests, and it is same as when a student learns things in the supervision of a teacher. Now we can see the working of supervised learning by this given example. Suppose we have a data set of different types of shapes, which includes squares, rectangle, triangle, and polygon. Now this is called as labeled data because we have given the data and we have also told what each type of data represents. And now our next step is to train the model for each shape. This is the label data and this is the labels which tell which shape is what. If the given shape has four sides and all the sides are equal, then it will be labeled as a square. And if the given shape, if it has three sides, then it will be labeled as a triangle. And if the given shape has six equal sides, then it will be labeled as a hexagon, etc. Now, after training, we test our model using the test set. Here we have taken our test set as a square and a triangle. And the task of the model is to identify the shape. The mission, it's already trained on all types of shapes, and when it finds a new shape, it classifies the shape on the basis of number of sides and predicts the correct output. Now after prediction, it has predicted the shapes correctly as square and triangle. Now, as I have also mentioned before, the aim of a supervised learning algorithm is to find a mapping function to map the input variable x with the output variable y. Now, coming to the advantages of supervised learning. With the help of supervised learning, the model can predict the output on the basis of prior experiences. In supervised learning, we can have an exact idea about the classes of objects. The supervised learning models helps us to solve various real-world problems such as fraud detection and spam filtering. Though supervised learning has many advantages, it does have some shortcomings. Supervised learning models are not suitable for handling complex tasks as it cannot predict the correct output if the test data is different from the training dataset. For example, in the training dataset, we have given only three shapes, that is hexagon, triangle, and square. And if suppose we give a circle in our test data, our model it cannot predict what type of shape it is. That's what is meant by test data has to be from training dataset. And another disadvantage of supervised learning is that it has high computation time compared to other types. These are the advantages and disadvantages of supervised learning. This supervised learning it can further be classified into two, which is regression and classification. Regression algorithms are used if there is a relationship between the input variable and the output variable. This can be explained with a simple example. Let's if we take a 2D graph, that is x-axis and y-axis. The x-axis it may be the input variable and y-axis it will be the output variable. In other terms, we can say that x is the independent variable and y is the dependent variable. For a given value of x, our model it has to predict the correct value of y. This is nothing but regression algorithms, and it is used for the prediction of continuous variables. We'll be seeing regression in detail in upcoming slides too. The other one, it's classification. Classification algorithms are used when the output variable is categorical. Now let me explain this with another simple example. For example, we have a data set which contains the images of cats and dogs. Now, the aim of our model is that when we give a new picture, we don't know if it's a dog or a cat, and it's the task of our model to tell us whether the image is a cat or a dog. For this, the classification algorithms will be used. Which in this there will be there can be two classes or more than two classes. We will be seeing classification in detail in the upcoming slides too. Regression versus classification. As I said before, the in the regression, the output variable must be of continuous nature or real value, whereas in classification, the output variable must be a discrete value. In this regression graph, the orange dots it represents the data points, and this line it's called as the line of regression. We'll be seeing all this in detail. The other one is classification. The green dots it represents a particular class of objects, and the blue dots it represents another class of objects. Now this line is called it is the boundary line which separates the majority of the data points, so that if we have a new point, the model it can predict whether it belongs to the green uh, data points on the left or it belongs to the blue data points on the right. In classification, we try to find the decision boundaries which can divide the dataset into different classes, whereas in regression we try to find the best fit line which can predict the output more accurately. Regression can further be classified into two. It is linear and non-linear regression. Whereas classification, it can be Whereas classification, it can be classified into binary classifier and multi-class classifier. Now we will be seeing regression in detail. As I said before, regression, it's a process of finding the correlation between dependent and independent variable. This linear regression is one of the easiest, it hosts one of the most of the easiest algorithms in machine learning. Now coming to the types of regression algorithms, I have mentioned a few, which includes simple linear regression, regression trees, non-linear regression, Bayesian linear regression, and polynomial regression. We will be seeing simple linear regression in detail. The In this linear regression, it is used to predict the value of a variable based on the value of another variable. And the only difference between linear regression and non-linear regression is that in linear regression, we'll be having a straight line as the line of regression, whereas in non-linear, we'll be having a non-linear curved line. Not it will having a curve which predicts the value of the dependent variable based on the independent variable. The other one, it's polynomial. The under non-linear regression, the function, it may be either logarithmic and exponential, and other types are also possible. In polynomial regression, it is a form of regression analysis in which the relationship between the dependent variable and independent variable is modeled as an nth degree polynomial in X. The last one, it's regression tree. The regression tree is basically a decision tree which is used to predict the value of the continuous output variable, continuous output instead of discrete output. Now next, coming to classification, it is a process of finding a function which helps us to divide the dataset into classes based on different parameters. Now we will be um, um, seeing the KNN algorithm in detail. In that algorithm, the parameter that we are going to use is the distance between the new point and the already given data points in our data set. In classification, a computer program is trained on the training data set, and based on the training, it categorizes the data into different classes. Some of the classification algorithms include K nearest neighbors, support vector machines, random forest, decision trees, and naive Bayes. We'll be seeing KNN algorithm, which is a simple algorithm that stores all the available cases and classifies a new case based on a similarity measure. The most commonly used parameter for similarity measure is the distance between 2 points. The next one, it's decision tree. It is a, as we are seeing, this is a type of supervised machine learning. This is used to predict the output based on how the previous set of questions were answered. And the next one is random forest. Random forest is a supervised learning model that is widely, it is the specialty about random forest is that it is used both in classification and regression problems. And in that, it builds the decision trees on different samples. And if it's a classification problem, we give the output from the majority vote, and in the case of regression, we give the output from the average. Now we'll be seeing simple linear regression algorithm in detail. Linear regression is one of the easiest algorithm in machine learning. It is a statistical model which attempts to show the relationship between two variables with a linear equation. Regression analysis, it can be also said as a form of predicting modeling technique which investigates the relationship between a dependent and independent variable. As we are seeing here, it involves graphing a line over a set of data points that most closely fits the overall shape of the data. Here, the data points that we have, it's represented by blue points, and the line which passes through the data points, it's called the line of regression. And the characteristic of the line of regression is that it has to fit the overall shape of the data, and it will predict the value of the independent variable which is given by the y-axis. This regression line shows the changes in a dependent variable on the y-axis to the changes in the explanatory variable, or otherwise called as independent variable, on the x-axis. Now this line, as we know, a line can be represented as y equal to mx plus c, or otherwise I have taken the constant as a naught and a1, and this epsilon at the end of the equation, it's called the random error. For a ideal model or a good model, this random error, it has to be minimal, or or we can say that in an ideal model this random error, it's zero. This y, it's our dependent variable, x, it's our independent variable, a naught and a1 are the linear regression coefficients, whereas where a naught gives us the y intercept, that is where this graph would touch the y-axis. Now our task is to find the constant a naught and a1, and from the next slide onwards I'll be taking this a1 as m and a naught as c for easier understanding. Okay, now if we see this in the first graph, the x-axis represents the independent variable and y-axis represents the dependent variable. And the light blue colors, it's the data points. And let us assume we have already drawn our line of regression. And for this particular value of x, our line of regression, it predicts the value here. It is represented by the red colored point, which is nothing but the estimated value. But we see here that the actual value, it's far from here, and the distance between the estimated value and the actual value gives us the error. Now our main goal is to reduce this error between the estimated and the actual value. We'll be seeing how we can uh, reduce this error in the upcoming slides. Okay, now let us consider a very small data set of x and y, where x is the independent variable and y is the dependent variable. For each value of x, we have a corresponding value of y. For example, for when x is equal to 1, we have y equal to 3. Likewise, for x is equal to 1 to 5, we have the values of y. Now, the statistical formula to find the value of m, it is given by this formula, which is nothing but sum of x minus x bar into y minus y bar divided by sum of x minus x bar the whole square. The derivation of this statistical equation, it will take a whole new event to explain how we got this formula. Now if we see the value of x minus, first we have to find the mean value of x, which is nothing but the mean of the numbers from 1 to 5. We get it as 3, and the mean value of the values of y, we get it as 3.6. We are finding the mean values of x and y because we have x bar in our equation, which is nothing but the mean values of x and y. Now the value of x minus x bar, it's, and now I am talking about the third graph. The value of x minus x bar, it's nothing but the this, now this x is equal to 3, it's the blue colored line that is drawn here, and the value of x minus x bar, it's nothing but the distance between the data points from this line. Now if we see, let us consider this one example where x is equal to 1 and y equal to 3. That is the first example. Now the distance between the point and the line is given by 3 minus 1, which is 2. That is nothing but x minus x bar. Now this x minus x bar, it can be either in positive or negative, because it depends from which side of the line we are measuring the distance. Thus, on the same uh, way, we find the value of y minus y bar. Y minus y bar is nothing, is the same as the value of x minus x bar, where we find the distance of the data point from the mean value of y. Here our mean value of y is 3.6, and here we have our data points which are represented in blue color, and we find the distance and we tabulate in our table. After finding values of x minus x bar and y minus y bar, next we have next we have to find the values of x minus x bar the whole square. We just have to square this value and write it, and we have to multiply x minus x bar into y minus y bar, and we write that in our table too. And then now if we add all the values under this fifth column, which is 4 plus 1 plus 1 plus 4, we get it as 10. And for the uh, summation of our numerator, we get the sum as 4. And now if we substitute this value 10 and 4 in our equation for m, we get it as 4 by 10, which is nothing but 0.4. Now if we see this dotted line, it's in the graph, the dotted line represents our line of regression, and this blue colored line, it represents our mean value of x, and this orange colored line, it represents the mean value of y. Now we can clearly see that this point of intersection of the mean value of y and mean value of x passes through our regression line, which means that we can substitute the values of the mean value of x, that is 3, and mean value of y, that is 3.6, in our equation y equal to mx plus c. We have already found the value of m as 0.4, and then if we substitute x is equal to 3, y equal to 3.6, and m equal to 0.4, we can get our value of c as 2.4. Now that we have found all the constants in our line, in our regression line, we can write our line equation as y equal to 0.4x plus 2.4. Now this is the final equation from which we can predict the values of y from the given values of x. Now for we have seen these things, and we can predict values of y for x. Let us take the same numbers that we have taken as the actual value, x equal to 1, 2, 3, 4, and here we are predicting the values of x. We are predicting the values of y based on x. If we substitute x equal to 1 to 5 in the equation, we get the predictor values like this. And if we plot these values in a graph, and then if we compare this with the actual value, you can see that some points are near to the line and some points are far to the line. And this is the best fit line, which would be the one which has the least error or the least difference in the estimated value and the actual value. Now we are finding the values of m and c, and we are drawing a line and we are predicting the values of y. But how we will know if the value, if it's the line that we have found now, is it accurate or not? Now for that we have various methods, but one of the popular one, it's R square value. R square value is a statistical measure of how close the data are to the fitted regression line. It is also called as the coefficient of determination or the coefficient of multiple determination. Greater the R square value is, more close are the data to the regression line. Suppose we get the R square value as 0.80, which means that our line of regression, it can explain 80% of the values of y with the given values of x. The formula for R square is given by summation of yp minus y bar the whole square divided by sum of y minus y bar the whole square. Here yp is the predictor value of y is the actual value of y, and y bar is the mean value of y. In this, the mean value of y will be constant in the whole summation process, but the values of y will change for each value of x. Uh, we will be seeing the implementation of simple linear regression at the end. Before that, we will be seeing the an algorithm under classification, which is k nearest neighbors. K nearest neighbors is an algorithm which is a fairly simple one, and it is very easy to understand and implement. And this is an algorithm that solves a classification problem. Basically, if we are given with a set of data points with known classes, and when we get to a new data point, we can predict the class of the new data point using our KNN method. Like I have said in the start, I gave an example for KNN. That is, I gave an example in general for classification. I have mentioned here the same. The simple class prediction gives rise to machines that can differentiate between cats and dogs, and even more sophisticated ones, it can identify the diseases from X-rays and MRI scans too. This is the beauty of machine learning. Now I will explain how this KNN algorithm works with another example. Now in this graph we have three types of flowers. This is these blue dots, it represents a type of flower. This green dots, it represents another type of flower, and this red dots, it represents another type of flower. And in this problem, which involves classification, we are given a set of data points and their classes, and we have to classify a new data point into its appropriate class. Now our new data point is p, and we have to say whether this point p, it belongs to the blue flowers or the red flowers or the green flowers based on the location of p. Now this graph, it is plotted based on the flower's sepal width, sepal length, petal width, and petal length, and then we have obtained the following petal width versus petal length graph. Here the features are input parameters with which we can draw certain correlations and how they affect the output. The flower dimensions in this case are the features. The flower dimensions, it's nothing but this the width, length, and the this petal width, petal length, sepal width, and sepal length. And the labels are the output parameters which we are supposed to predict. In this case, we have only one label which which corresponds to the species of the flower. Now, given the properties of a new flower P, that is the one which is here, we can confidently say that it belongs to the type of flower encoded by blue. Now we can say that the point P belongs to blue colored flowers just by seeing. But how we can train a computer system to do the same? The math behind Canaan is very simple. We just need to calculate the Euclidean distance between the 2 points. Now, if we consider 2 points A and B, whose locations are given by x1, y1 and x2, y2. This is simple maths. We just have to use Pythagoras theorem to find the distance between point A and B. This is given by d square. D is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Therefore, we can find the distance, and we can also extend this idea to three dimensional locations. If we consider this points P, Q, or S, we can find the distance between P and S by using the Pythagoras theorem twice. First, we have to find the distance between P and R. For that, we take the distance PQ as A and QR as B, and then distance between P and R, it's given by square root of a square plus b square. Again, we have to consider the triangle PSR, and then where the distance between S and R is C, and we again apply Pythagoras theorem. We get the value of the distance PS as square root of a square plus b square plus c square. Now this can also be extended to n dimensions, but it will be really hard for us to visualize them. But it doesn't stop us from uh, giving the general equation, where n it represents the dimensions. If n is equal to 2, we get only 2 terms, and for n equal to 3, we get 3 terms. It is given as square root of summation of I equal to 1 to n x my x I2 minus x I1 the whole square. Now this is the same as we have did before, but I have given with the actual algorithm how we will be using. The KNN algorithm works is that the program calculates the distance between the unknown points and all the known points. If we consider, we are taking here 2 points P and Q, and we have to find the distance between the point P and the other data points which are near it. The we have a parameter called as K. Here K represents how many data points that we are going to compare with our new data point. That is, we consider the first k shortest, and then we only consider the k first shortest distances and their labels, and based on that we predict whether the our new data point it belongs to which class. Each of these k distances it gives us a vote. Now if we consider this point q, and we have taken our value as k equal to 3, which means that we will be considering only the 3 uh, nearest data points to the value q, and from that we will be predicting whether it belongs to blue or green. Here obviously we can say that all the points belong to blue, so that the votes that we get are blue, blue and blue. This means that this means we can classify the point q as blue with a confidence of 100%. Now next, if we consider the value p, here again we are taking k equal to 3, which means that we will be considering the classes only of the k, that is 3 nearest data points. Now here we are getting the votes as green, blue and again green. This is because the closest point is green, and the second closest point is blue, and the third closest point is green. In this case, we can classify the point P as green, but only with a confidence of 67.67%, just nothing but 2 by 3, because in the votes we have 2 points as two votes as green and one votes as blue, and we have done the same. And here I have mentioned as the label with the most votes is assigned to the unknown point. In the first case, we have assigned blue to the point q because the majority is blue, and we have given the value, the label green for the value p for the new data point p. Now this is the actual algorithm for KNN, and the first step it is always to find the number k which we are going to consider, and the next step is to calculate the distance between the given data point, that is the new data point, and the already existing data points. The third step is to take k nearest neighbors as per the calculated Euclidean distance. And the fourth step is to find the votes, that is whether the class of the nearest data point is it blue or green. That is the fourth step. Among these k neighbors, count the number of data points in each category. And the fifth step is to assign the new data point to the category for which the number of neighbor is maximum. For the point q, we have assigned the value as blue, and for the point p, we have assigned the value as green. Now this is how KNN works, and our model it's ready. Now, how to find the value of k? Uh, the finding the value of k is very important so that we can get the best out of our model. The process by which we find the value of k is called hyperparameter tuning. If the value of k that we are going to consider, if it's very small, the error rate of the model will be large, especially for new data points, since the number of votes considered is very small. Now, for example, here we have considered k as 3. But if we consider k as 4 for this point P, we will be considering the 4 points, which will give us green, 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 and blue. That's the I'm telling the votes. So we will be getting a higher confidence level as 3 by 4 instead of 2 by 3. But it varies from our model to model, for which uh, each model will have a specific value of k for which we can get the best out of that model. If the value of k is very small, the model is said to be overfitted and it is highly sensitive to noise in the input. On the other hand, if the value of k is large, then the model's boundaries become loose and the number of misclassifications increase. In this case, the model is said to be underfitted. Though there are no Though there are no fixed methods to find the value of k, we can follow these simple two steps to find the best value of k. The first one is that we have to set k as an odd number so that we will have an extra point to settle tiebreakers in the extreme cases. For example, if we consider k value as 4 and in the votes we get 2 blue and 2 green. Now, in this case, we cannot tell if the new data point belongs to blue or green. So that's why we set k as an odd number to settle the tiebreakers in the extreme cases. And the next one is that we have to give the decent value of k can be the square root of the number of data points involved in the training data set. Where here k is, we can take k approximately equal to square root of, we can take k as approximately equal to square root of n, where n is the number of data points in our data set. Uh, Even though this KNN algorithm in machine learning has many shortcomings, they can be patched with certain modifications and improvements, which makes it one of the most powerful classification algorithms out there. Now, that's it from the theory part of machine learning, supervised learning, and types of supervised learning. And I have taken I have taken references from the given web pages. I will be sharing this PPT after this event. You can check this out to learn more about them. Now we will be seeing the practical implementation of simple linear regression and KNN algorithm using Python. Now we are going to implement simple linear regression using Python. In in all the programs, the first step is to import the libraries. The need for the libraries is that it would contain all the functions and methods so that we need not code the entire thing again. Here we are taking three important libraries, which is NumPy, which contains all the math related functions and methods. Next one is matplotlib to plot or graph, and next is pandas. It is a machine learning which contains the functions of ML. Here I am importing these three libraries first, and the next one we should have a data set from which we can predict the output from the input. Here I am taking the data set as I am taking a data set in which this is the actual data set where we have four columns. The first column and second column we are not going to consider in this problem. We are going to consider only the head size and brain weight. This head size, its unit is given by centimeter cube, and brain weight it's given in grams. We are going to take the independent variable, that is x as head size, and we are going to predict the brain weight from the given head size. For that, I am using Python. For this, I am using this pandas library function, which is pd.read underscore csv. This is the name of the uh, dataset that I have imported to this program. Now to see the preview of the uploaded CSV file, we just print data.head. We have made a variable data from which we will be calling each time. Data.head returns us the table. We have, as you have given, we have mentioned as head, it would return us only the top 5 data points. That is from 0 to 4. The size of our dataset is that it contains 4 columns and 237 rows. That is given as 237, 4. Now we are storing the values of head size and brain weight in variables x and y respectively. X equal to data. This is nothing but the if you know about the lists in Python, then we can uh, understand these things more easily. Now first we will be implementing simple linear regression using the statistical formula. That is, we will be using this formula. We will be finding the value of m first. That is summation of x minus x bar the whole into y minus y bar divided by summation of x minus x bar the whole square. Now, uh, to find the mean value of x, we again make use of the numpy library, and the mean value is stored in a variable mean underscore x. And similarly, we find the mean value of y and store the value in mean underscore y. And the total number of values, it's stored in a variable called as m. Now this is our formula to find m. I have taken uh, some other variable names, but it is same as m and c. This first initially we are giving the values of numerator and denominator as 0, and we are using a for loop to just add the values in each iteration. Numerator is x minus mean of x into y minus mean of y. This is same as x minus x bar into y minus y bar, which is nothing but our numerator. And in the denominator, we each time we add the value of x minus x bar the whole square. This plus equal to, it's just we are adding the numerator and denominator for each value of x. The each value of x means we have m values of x, which is given by the length of the x. That is, we have 227 values of x and 227 values of y. So this loop, it will run for 227 times to find the sum of the x minus x bar into y minus y bar, and in the denominator to find the value of x minus x bar the whole square. To find the value of b1, we are here b1, it is nothing but m. Here we are dividing the numerator by denominator, and the value of b naught, it's nothing but c, which is we are substituting the value of x as mean of x, value of y as mean of y, and we are substituting the value of b1 in the place of m. And if we print the regression coefficients, that is b naught and b1, we get these values. Now I'll be graphically showing the regression line and the data points. Now first we will be defining the size of our graph, that is max of x equal to max of x plus 100. That is so that we'll be having an extra 100 so that our graph, it won't look clumsy. That's the significance of the first two lines. And you are calculating the values of x and y. This linspace, we would have seen this in MATLAB, which is nothing but we have given the starting value of x and the ending value of x, and this linspace function, it would simply generate 1000 values of x from the starting point to the end point, and it is stored in the variable small x. And then we define another variable small y in which we store the value of y based on our predictions. Now to plot the line, we use the function mtp plot, mtp dot plot. Here mtp it's nothing but matplotlib. I have taken it as mtp. mtp dot plot, here x and y are the values of x and y that we are going to consider, and this is nothing but color and the label. The color is I have given the hexadecimal values, and the label for this thing is regression line. And then in the next thing, we are plotting the scatter points, which is nothing but the orange colored points. The same way we are giving the parameters capital X and capital Y, which are nothing but these values. That is from 4512, the corresponding value is 1530. Here we have given as capital X and capital Y. And the actual values of X and Y, it's given as small x and small y. We give the same parameters and I have given a color in hexadecimal, and I have labeled this as scatter plots. And I am giving the x label as head size in centimeter cube, because I have told initially that this head size it's going to be our dependent variable, the not dependent, so independent variable in x-axis, and brain weight it's going to be our dependent variable in y-axis. That's why I have given the x label as head size and y label as brain weight. Now this mtp.legend means it will just show what's what. This orange dots, that is our data points. It it is the scatter plot, whereas the green colored line it's our regression line. mtp.show shows our graph. Now we can see that the orange ones are the data points and the green line is the line of regression. The line of regression is such that it passes through, it covers all the data points, and the distance between the actual and the estimated value is minimal. Now we are finding the value of r square, that is the coefficient of determination, from the statistical formula that I have discussed here, which is summation of yp minus y bar the whole square divided by summation of y minus y bar the whole square. I have implemented just the same here. We have again taking numerator and denominator as 0, and we will be having m number of points, so that we are using for loop from I equal to 0 to m, and predictor value of y is given by, we just substitute the coefficient that is m and c. I'm taking here as b1 and b0 in our equation, and we substitute the values of x. Here I have given x and then this square brackets in I, because it would fetches the ith value of x from our list. And then the numerator, as it's given here, yp minus y bar the whole square. The same I have given here as y y underscore prediction, which is nothing but yp, and minus mean of y, that is y bar whole square. I have given two asterisks and 2, and the same way in the denominator it is y minus y bar, that is y square brackets I minus mean of y. Two asterisks means it will give us the square value, and then we find the we get the r square value as numerator by denominator. We print the r square value and we get it as 0.639. This means that our regression line, it can explain 63% of the uh, values of y for the given values of x. That is the meaning of r square. Now here we have manually implemented the linear regression. Now in the next cell, I have made use of the scikit-learn library in Python, in which all these will be already pre-coded in a function, and with that help of the function, we can predict the values of y in just small this small within the small number of lines of code. We can implement simple linear regression. For that, we are importing this linear regression, and for the prediction of values of y, and mean squared error to find the value of r square. We are importing these two functions from scikit-learn. First one, it's from scikit-learn dot linear model, as this comes under linear type. And then the next one, we are importing from the we are importing the function from sklearn dot metrics. Now this first step, that is x equal to x dot reshape dot m comma 1. Here m is the size of our data set. We cannot use rank 1 matrix in scikit-learn. If we use the x as such, we will be having a one dimensional graph. But the scikit-learn library, it cannot make predictions using one dimensional array. So we are changing the dimension as 2D. That is, the m it's one dimension and the other dimension it's one. In total, it has two dimensions. In the next line, we are creating the model. We are naming our model as reg, which represents regression, and the name of the function is linear regression. In the next step, we are fitting the training data, that is the values of x and y. The values of x and y are nothing but head size and brain weight. We are fitting the values of x and y, and in the next step we are predicting the values of y. For that, we use the function dot predict of x. That is, we are giving the values of x for which it would predict the value of y. Now if I run this, I will get 230. What's the size of our data set is 237. Now if I just run this ypred equal to reg dot predict of x, we will be getting 237 values of y for each value of x. Now if we click that, if we run that line, means we will be getting 237 values of y. We need not see all the values of y. We just want to know how close are the values to the actual value. For that, we use the function dot score x comma y, where x and y are the parameters, x is the independent variable and y is the dependent variable. And when I print the value of r square, we get the same as 0.639. It is the same as we have done, as the value that we have got from the manual implementation using statistical formulae. Now, this is the whole thing for simple linear regression. I hope everyone understood the coding. I will be uploading both the data set and the coding in a drive, and then it will be shared after this event. The next one that we are going to see, it's the implementation of k nearest neighbors. For this, again, we import a lot of functions. We'll be mostly using these libraries only. First, we have imported pandas, then numpy, and then from sklearn, we are importing various functions. That is train test split, standard scaler, k neighbors classifier, confusion matrix, f1 score, and accuracy score. As we have seen in the that is in linear regression implementation, the first step is to load the data set. I'm using the same syntax here as I took here, as I took there. Here we are taking another classification data set, which is based on diabetes. Here we have 9 columns, which would predict if the person, if he has diabetes or not, based on the given features. The features are, if the person, if she is pregnant or not, the glucose level, blood pressure, skin thickness, insulin level in the body, BMI is nothing but body mass index, diabetes pedigree function, and age. Based on this 3, 4, 5, 6, 7, based on these 8 features, we predict if the person, if he has diabetes or not. It is given in the last column, that is outcome. Here, one, if the value is 1, means the person has diabetes. If the value is 0, means the person does not have diabetes. Here, if we want to know the size of our data set, we print we give the syntax print len of data set. We get the value as 768, which means that there are 768 values like this. Dataset.head returns us the it returns us the first 5 values in our data set. Now, if we see in some of the columns, we have 0 as one of the values. Now, this 0, it would cause us a major headache in in machine learning, as it may switch the mean value very far off from the actual mean value. For that, for that we will be replacing the values of 0 from the mean of other values in the column. Now we have this columns such as glucose, blood pressure, skin thickness, BMI, and insulin, where we cannot have 0 as one of the value. For that, we iterate to the whole data set, and we wherever we have the value as 0, we replace that value with none, which is nothing but undefined. If the, for example, in this insulin column, we have the value 0 in the first, the that is in first row, second row, and third row, and this dataset column equal to dataset column dot replace this line, it would replace this 0 with the thing undefined, and in the next step we find the mean of the other values, that is we find the mean of from 94, 168, and other values that come after this, we find the mean of that value, and we skip the values 0 if the value is given as not defined, and then in the third step we again replace this values of 0 with the mean value that we have calculated. That is the work of this part of code. We are replacing zeros with undefined, and then in the next step we find the mean excluding the values of undefined, and in the third step we replace the undefined values with the mean value. Now here we are going to split our total data into two, that is into training and testing data set. So that first we will be developing a training data, that is we'll be creating a KNN model using the training data set, and with the help of the training data set we will be feeding a new test data set from which we will be we can tell that if the model if it predicts the uh, dependent variable, that is the class of the object, correctly or not. For that, in the previous we had only two features, that is x and y. Here as we are having a lot of features, that is we have around 8 features, we take the value of x from 0 to 8. Here 8 means it will take only up to 7, and that is our features, and the label, that is the last column, outcome is our label, that is our output, that we are taking only the 8th column, and the x we are taking from pregnancies to age, it will be x, and only this outcome it will be y. That is the meaning of the first two lines, and we are splitting our data into two, that is training dataset and testing dataset. For that we have x train and y train, and then x test and y test. For this we use the syntax train underscore test underscore split. We have three parameters x, y, that is the input x and the that value that we are going to predict y, and then we take the random state as 0, and this test size is nothing but in under what ratio that we are going to split the training and testing dataset. Here I have given the test size as 0.2, which means that the 80% of the data will be going into training dataset, and 20% of the data we will be using that as testing dataset. Now an important step that we have to follow is that it is feature scaling, and any algorithm that computes distance or assumes normality, it is important that we scale our features. As we are going to use the Euclidean distance as one of the measures, it is important that we scale our features. For that, we call the function standard scalar. We s- feature scale the values of the x training and the values of x in both in training dataset and in test dataset. That's the uh, coding that is given here. And then, as I have mentioned here, the two simple methods to find the value of k. The first one, it is to set k as odd number, and the next one, it is to set the k as a square root of n. That I'm doing here. For that, we import a library math to find the square root, and then the length of y test, it's nothing but the size of the data set. That is n, as I have mentioned here n. Here the value of n is given by length of the size of testing data set. We get the value as 12.4, so that the nearest value, which is both an odd number and which satisfies our condition, it's 11. So we subtract 1 from 12 and we use k equal to 11. Now we are defining our knn algorithm function. We name it as classifier. We call the function k neighbors classifier. We have three parameters, where the first parameter is n underscore neighbors, that is the value of k. We are taking the value of k as 11, and p value is 2. And the measure that we are going to consider here, it's Euclidean. That is, will be the function, it will be based on the distance between the new point and the already existing point in our graph. So that for that we are mentioning the metric as Euclidean, and we are fitting data into the model. For that we use the function dot fit x train comma y train. First we are training the data set, and then we'll be testing the model with a testing data set. In this line, I have fitted the values of x and y into our model, and then we get the output. And in the next step, we predict the values of y from the test dataset. We define a variable y predict, and then we call our model that we have named it as classifier. Classifier dot, this dot predict, it will predict the values of y from the given values of x. Here I have given the parameter as x test, so that we get the values of x from our testing dataset. And then if I have to see the output, I just type y predict, and then if I press and if I run this, I get an array which includes ones and zeros. As I have told in the first itself, if the outcome is 1 means the person he has diabetes, and if the output and if the outcome is 0 means then the person does not have diabetes. Now for the given values of x, our model, it has predicted the value of y. Here we have ones and zeros, where 1 represent the person has diabetes, 0 represent the person does not have diabetes. Now we have predicted if the person has diabetes or not. How can we evaluate if our model is the accuracy or precision of our model? For that, the commonly used method to find the efficiency or accuracy of a model, we have something called as confusion matrix. In this, we take two parameters, that is the actual value of y and the predicted value of y. We store this in a variable called as cm, that is confusion matrix. And if we print confusion matrix, we get an array like this. Here let me explain what a confusion matrix is in simple words. Here we have values 94, 13, 15 and 32. Here 94 is nothing but the person does not, here the, let's consider it has x-axis and y-axis. The here it is 0, here it is 0, 0, 1, 0, 1. The 94 means that the person does not have diabetes, and the model, it has told that these 94 people do not have diabetes, which means that it is true negative. That is, the actual person does not have diabetes, and in the predictor model also it has told that the person does not have diabetes. But this 13, here our model has predicted that 13 people do not have diabetes, but in the actual data set, 13 people they actually have diabetes. The next one it is nothing but this here it will be 1 and here it will be 0, and our model it has predicted that 15 people do not have diabetes. The 15 people have diabetes, but in the reality 15 people they do not have diabetes. So this value 15 and 13 these are the false values, whereas this 32 our model it has predicted that 32 people have diabetes, and in the actual da- data set to 32 people have diabetes. So these 94 and 32 are the correct values that we have got in output, whereas 13 and 15 are the counter values, that is the incorrect values that our model has predicted. Now to predict the precision of this model we have something called as F1 score. The background of F1 score it has a lot of things to discuss. For just for understanding we can say the value of F1 score as how precise our model is. We get it as 0.6956. You can say that our model is 69% precise. The next one is to find the accuracy of model. Both the F1 score and accuracy it's important to tell whether our model is um, efficient enough or not. For that we use the syntax print accuracy underscore score, and we give the two parameters as the predictor values of y and the actual values of y. The actual values of y it's given by y underscore test, and the predictor values of y it is represented as y underscore predict. We get a accuracy score of 0.818, which is nothing but 81%. Now this is the implementation of knn algorithm using Python. I'll also upload this file and along with the dataset so that you can implement and see in your systems. Now this is it from my side, and thank you for giving me this opportunity to talk on machine learning. And don't forget to see our Instagram handles, and please do follow the same, and please do follow our YouTube channel. Thank you. Nishit, are you there?